Hello everyone, I am Teacher Michelle and welcome to another episode here in Unang Math. Our topic for this episode is still about prime factorization, and this is part 2 of this topic. In the previous episode or episode 47, we already studied what is prime factorization. This part 2, we will study the use of prime factorization. How to use prime factorization, or what can we do after knowing the prime factorization of a number. This episode is divided into 2 parts. In the first part of this episode, I will discuss how to find the factors of a number using its prime factorization. I know that you already know how to find the factors of a number, and you might even do that mentally. But if the given number is a big number, then it's difficult to find or list all the factors, and you might even miss one of those factors. That is the use of prime factorization that I want you to learn. We can easily find all the factors and save time. In the second part of this episode, we will answer various problems using the concepts and understanding we had in the first part. So in this time, I want you to focus and concentrate so you can easily grasp the idea and process. Let's begin with finding the factors using prime factorization. Before we will do that, you need to understand first these 2 forms of numbers that we will encounter in this topic. The first one is the form of the factors of an exponential number. Okay, let's give an example. What are the factors of 2 raised to the power of 3? 2 raised to the power of 3 is an example of an exponential number. We don't know how to find the factors of an exponential number, but we can convert an exponential number to a natural number because we know how to find the factors, or we know how to find the factors of a natural number. Okay, let's convert. 2 raised to the power of 3 is equal to 2 times 2 times 2, and this is equal to 8. 8 is a natural number. Okay, what are the factors of 8? We have 1 and 8. We also have 2 and 4. So there are 4 factors of 8. Always remember, 1 is always a factor of a number. Okay, now let's convert 2, 4, and 8 to an exponential number. 2 is 2 raised to the power of 1 or 2. Okay, how about 4? 2 raised to the power of 2 or 2 squared. 8 is 2 raised to the power of 3. Okay, copy 1. So we have 1, 2 raised to the power of 1 or 2, 2 squared, and 2 raised to the power of 3. These 4 are all factors of this exponential number, 2 raised to the power of 3. So how do we know, or how do we find the factors of an exponential number? Okay, this exponential number 2 raised to the power of 3. Okay, always start with 1 because 1 is always a factor of a number. Next, we have 2 raised to the power of 1 or 2, the number or the base. Next is 2 squared, okay, until we arrive to the same number, 2 raised to the power of 3. And to know how many factors an exponential number have, all we have to do is the exponent, so we have 3, okay, plus 1, because 1 is always a factor of a number. So 3 plus 1 equals 4. So there are 4 factors of this exponential number. Okay, one more thing that you need to know. The base of an exponential number is a prime number. If the base is not a prime number, then it's not correct. Okay, another example. This time, what are the factors of 3 raised to the power of 4? We don't need to convert this exponential number to a natural number because we already know how to find the factors just using the exponential number. Okay, let us list all the factors of 3 raised to the power of 4. Okay, we start with 1. Next is 3 raised to the power of 1 or 3, the base or the number itself. Next is 3 raised to the power of 2, 3 raised to the power of 3, until we arrive to the same number. So lastly, 3 raised to the power of 4. So there are 5 factors of this exponential number. Okay, let's see. The exponent is 4, okay, plus 1 equals 5. So there are 5 factors of this exponential number. And the base of this exponential number is a prime number. So this is correct. Okay. In an exponential number, the factors of the natural number a raised to the power of n are, okay, we start with 1, a raised to the power of 1, a raised to the power of 2, a raised to the power of 3, until we arrive to the same, okay, number. And to know how many factors, n, or the exponent, plus 1. Okay, let's have the second form of number. This time, the form and count of factors of a natural number. Okay, example, what are the factors of 75? Okay, some of you can easily list all the factors of 75, but some cannot. 75 is a big number. To ensure that all the factors are listed, okay, we need to use prime factorization. So let us find out the factors of 75 using its prime factorization. So let us find out first what is 75's prime factorization. Okay, let's use division method. 75 divided by 5, this is 15. 15 divided by 5, 3. So the prime factorization is 3 times 5 squared. Okay, this is 75's prime factorization. Okay, this means that 75 is equal to all the factors of 3 times all the factors of 5 squared. Okay, what are the factors of 3? Since this is a prime number, we only have 2 factors, 1 and the number itself. Okay, how about 5 squared? What are the factors? 1, 5 raised to the power of 1 or 5, and 5 raised to the power of 2. Okay, to find all the factors of 75, we need to multiply all these numbers together. 1 times 1, 1 times 5, 3 times 1, 3 times 5, 3 times 5 squared, okay, and so on and so forth. Okay, to make sure that we can list or write all the factors, okay, we will make a table. All the factors of 3, we will write vertically. All the factors of 5 squared, we will write horizontally. So 1, 5, and 5 squared. And we draw or make a table. So we need to multiply all these numbers to find all the factors of 75. So 1 times 1 is 1, 1 times 5, 5, 1 times 5 squared is 25. 3 times 1 is 3, 3 times 5, 15, 3 times 25, 75. So 1, 3, 5, 15, 25, 75. These are all factors of 75. Okay, we got 6 factors. Let us check. 3 has 2 factors. 5 squared has 3 factors. 2 times 3, 6. So there are 6 factors. So we got all the factors correctly. So when a natural number n is prime factorized as n is equal to a raised to the power of m times b raised to the power of n, where a and b are distinct prime numbers. the form of the factors of n. So we're talking about the factors. So the form of the factors of n is, okay, factors, okay, of a raised to the power of m times all the factors of b raised to the power of n. Okay, how about the form of the count of n? So the form of the count of n is, we have m plus 1 times n plus 1. Okay, don't worry if you didn't understand this part, as long as you understand the process. Okay, let us answer this one. Find factors of 18 using prime factorization. Okay, 18 is just a small number, so we can easily list all the factors of 18. But since we are practicing to use prime factorization to find the factors of a number, okay, we will use that process. Okay, so first we need to find 18's prime factorization. Okay, let's use division method. 18 divided by 2, 9. 9 divided by 3, 3. So 18's prime factorization is 2 times 3 squared. Okay, now that we know the prime factorization of 18, okay, let's write this way. 18 is equal to 2 times 3 raised to the power of 2. 18 is equal to all the factors of 2 times all the factors of 3 squared. Okay, what are the factors of 2? Since this is a prime number, we only have 2 factors, 1 and the number itself. Okay, how about 3 squared? We have 1, 3 raised to the power of 1, and 3 raised to the power of 2. Okay, we need to multiply all these factors together so we can find all the factors of 18. Okay, to make sure that we can list or write all the factors of 18, we'll make a table. Okay, all the factors of 2, we will write it vertically. All the factors of 3 squared horizontally. So 1, 3, and 3 squared. Okay, make a table. Okay, we will multiply all these numbers together. 1 times 1 is 1. This is 3. 3 squared is 9, so 1 times 9 is 9. 2 times 1 is 2. This is 6. 2 times 9, 18. So we have 1, 2, 3, 6, 9, 18. These are the 6 factors of 18. Okay, let's check. 2 has 2 factors. 3 squared has 3 factors. 2 times 3, 6. So there are 6 factors of 18. This time, we will solve various problems involving prime factorization. But before we will do that, let us first answer these 2 questions that are often asked by students. The first question is, what happens when a prime number is prime factorized? To answer this question, let us give an example. 7 is a prime number. Let us find out what is 7's prime factorization. In finding a number's prime factorization, we just need to get all the prime factors and multiply together. Okay, what are the factors of 7? We have 1 and 7. But 1 is not a prime number. So we only have 7. So the answer to this question, what happens when a prime number is prime factorized? Prime number's prime factorization is the number itself. Okay, let's have the second question. How to find the factors of a number that has 3 or more prime factors, such as 180 is equal to 2 squared times 3 squared times 5. Okay, 180 is equal to 2 squared times 3 squared times 5. 180 here has 3 prime factors, 2, 3, and 5. And this means that all the factors of 180 is equal to all the factors of 2 squared times all the factors of 3 squared times all the factors of 5. So to find all the factors of 180, we will just do the same process. So get first or list first all the factors of 2 squared. So we have 1, 2, and 2 squared. List also all the factors of 3 squared. We have 1, 3, and 3 squared. Also, list all the factors of 5. Since this is a prime number, we only have 2 factors, 1 and 5. Okay, to know or to find all the factors of 180, since we have 3 prime factors, we cannot make or we cannot draw a table. So for us to find all the prime factors or all the factors, we have to multiply these numbers together. 1 times 1 times 1, 1 times 3 times 5, 1 times 3 squared times 5, 2 times 3 times 5, and so on and so forth. But this process is very long and complicated. So usually, in exams or in tests, they will not ask you to write or to list all the factors of a number that has 3 or more prime factors. But they will just ask you how many factors. So in here, 2 squared has 3 factors. 3 squared has 3 factors. 5 has 2 factors. So we just need to multiply these numbers together. So 3 times 3, 9 times 2, 18. Okay, it means 180 has 18 factors. Okay, this time, we are now ready to answer the following problems. Okay, the first problem is, which of the following is not a factor of 200? So we have 5 choices here. Okay, to find which is not a factor of 200, we have to find first the prime factorization of 200. Okay, let's use division method. 200 divided by 2, 100. 100 divided by 2, 50. Okay, continue dividing. 50 divided by 2, 25. 25 divided by 5, 5. So 200's prime factorization is, okay, 2 raised to the power of 3, okay, times 5 squared. Okay, this means that all the factors of 200 is equal to all the factors of 2 raised to the power of 3 times all the factors of 5 squared. Okay, what are the factors of 2 raised to the power of 3? We have 1, 2, 2 raised to the power of 2, and 2 raised to the power of 3. Okay, how about 5 squared? 1, 5, and 5 squared. Okay, this time, let's find out which is not a factor of 200. So all these factors and these factors multiply together. These are factors of 200. Okay, let's see. 2 raised to the power of 3. 2 raised to the power of 3 times 1 is 2 raised to the power of 3. So this is correct. 2 squared times 5 squared. 2 squared times 5 squared. So this is also correct. How about 2 raised to the power of 3 times 5? 2 raised to the power of 3 times 5. So this is also correct. 2 raised to the power of 3 times 5 squared. 2 raised to the power of 3 times 5 squared. So this is also correct. Next, 2 squared times 5 raised to the power of 3. Okay, 2 squared times 5 raised to the power of 3. Okay, we don't have 5 raised to the power of 3. So this is not a factor of 200. Okay, next problem. This time, the question is, how many factors does 280 have? Okay, to answer this question, first we have to find 280's prime factorization. Okay, let's use division method again. 280 divided by 5. This is 56. Okay, continue dividing. 56 divided by 2, it's 28. Okay, 28 divided by 2, 14. 14 divided by 2, 7. So 280's prime factorization is, okay, we have 2 raised to the power of 3, okay, times 5 times 7. Okay, this means that all the factors of 280 is equal to all the factors of 2 raised to the power of 3 times all the factors of 5 times all the factors of 7. Okay, the question is, how many factors does 280 have? Okay, 2 raised to the power of 3, the exponent is 3. So 3 plus 1. So 2 raised to the power of 3 has 4 factors. 5 has 2 factors. 7 has 2 factors. So 4 times 2, 8 times 2, 16. So the answer is 16. 280 has 16 factors. Third problem. When the number 3 raised to the power of 3 times 5 squared, or 5a, 3 raised to the power of 3 times 5 raised to the power of a has 24 factors, what is the value of the natural number a, or this exponent? Okay, let's represent this problem. This number, 3 raised to the power of 3 times 5 raised to a, okay, has 24 factors. Okay, this problem is asking for the value of this natural number a, or this exponent. Okay, 3 raised to the power of 3 has, okay, 3 plus 1. So it has 4 factors. Okay, 4 times, okay, this one, 5 raised to the power of a. So this means a, okay, plus 1. And this is equal to 24 because there are 24 factors. So 4 times what number? So the answer is 24. So 4 times 6. The answer is 24. It means A is 5 because 5 plus 1 is equal to 6. So the answer is 5. Okay, and our last problem. Among the following, which one has a different number of factors than the remaining 4? So to answer this problem, we need to find all the prime factorizations of each number. Okay, and let us find out which number has different number of factors. Okay, 12's prime factorization is 3 times 4, but 4 is not a prime number. 4 is 2 squared. Okay, 3 has 2 factors. So 2 times 2 squared has 3 factors. So 12 has 6 factors. Okay, how about 18? 18 is 2 times 9. Okay, 9 we need to write it as 3 squared. Okay, 2 has 2 factors. 3 squared has 3 factors. So 2 times 3, it has also 6 factors. Okay, how about 50? 50 is 2 times 25. So 25 is 5 squared. So 2 has 2 factors. 5 squared has 3 factors. So 2 times 3, it's equal to 6. So 50 has 6 factors. Okay, let's go to 63. 63 is 7 times 9. But 9 is 3 squared. So 7 has 2 factors. Okay, 3 squared has 3 factors. So the answer is 2 times 3, 6. So 63 has also 6 factors. Okay, how about 64? Okay, 64, what's prime factorization? Divided by 2, this is 32. Okay, divided by 2, 16. Divided by 2, 8. Divided by 2, 4. Divided by 2, 2. So the prime factorization of 64 is, okay, 2 raised to the power of 6. So 6 plus 1 is equal to 7. 64 has 7 factors. So the answer to this problem or to this question is this number, 64.